Okay, now we're going to look at what we call factoring a difference of squares. So, a difference of squares is a question. Here's a very simple example: x squared minus 9. And this looks different than any type of thing you've been asked to factor before. There's no common factors. It's not a trinomial. So, how do you do this? So, we want to factor this. Well, one way to do this would be to turn it into a trinomial. Remember, a trinomial is of the form x squared plus bx plus c, or you could have something in front of the x, but we don't in this case. Well, this is actually of this form, right? X squared, yep, I got x squared, minus 9, so that'd be like our c. Well, where's this? Well, we didn't write it, so what does that mean b is? B must be 0. So this is technically x squared plus 0x minus 9. Well, this I can factor, right? I need two binomials. The product must be negative 9, and the sum must be 0. Well, this is an interesting one. The sum is 0. If you have to add two things to get 0, what does that tell you about the two things? It tells you the two things have to be the same except the sign, right? If one thing was 3, the other one's negative 3. One thing is 5, the other one's negative 5. So that's kind of interesting right there. The product has to be negative 9. Well, the good thing about negative 9 is 3 and negative 3. 9 is a square. And 3 plus negative 3, remember we said they have to be the same except for the sign. That's 0. So this one must be x plus 3 and x minus 3. So this is what we call a difference of squares. So what makes it a difference of squares? Well, first, recognize the difference. So it's subtracting. And the second is, this is a square, right? X times x is x squared. And this is a square. 3 times 3 is 9. So it's a square. So you're going to see questions like this. X squared minus, and then this number has to be a squared, so I'll just say a squared. So remember, we could think of this as a trinomial, and at first, just to see how to do it, it's useful to think of it that way, but eventually, we're not really going to think of it that way. So the product has to be negative a squared, and the sum has to be, remember there's like a 0x there, so the sum has to be 0. Well, what multiplies to negative a squared but adds to 0? Well, remember, if it adds to 0, it has to be the same number but opposite sign. And if it multiplies to a squared, well, a times a multiplies to a squared, but it's negative, so negative a and a. So you're always going to get x minus a and x plus a. So it's always going to factor like this. So we'll just look at a couple examples. So x squared minus 25. So we know x, 25 is a square, so it's a square of 5 and 5. One has to be negative, one has to be positive. That's it. This should multiply out to give you this. Doesn't matter which one goes first, the negative or the positive. So x squared minus, 81. I think we did this example before. No, we didn't. So x, square this, 9, 9. One's negative, one's positive. Multiply that out, you'll get that. So that's it. It doesn't always have to be x squared, so you could have something like 4y squared minus 36. So this one's still going to be binomials. So now the first term must multiply to give you 4y squared. Well, that's a square, right? 2y times 2y gives you 4y squared. Then the last term, 36 is a square, 6, 6, 1's positive, 1's negative. Doesn't matter where the positive or negative go. Could be opposite order. That's it. Let's throw a to the power of 4 minus, oh, here's a good one, 16. So a to the power of 4, well, that's a squared and a squared, right? A squared times a squared is a to the power of 4. 16 minus 4 plus 4. Well, what do you notice? So we're good that if you multiply this out, you get this. But looking at this bracket, you maybe notice something. And that would be that that's a difference of squares also. So you can go further. A minus 2, a plus 2. And then this bracket, some people will be tempted to do this one, but notice it's a plus. So you can't factor, this would be a sum of squares. You can't factor a sum of squares. Actually, yeah. So let's say you had x squared plus whatever 4. This is not factorable. Over integers. Meaning you can't write it as a product of two binomials. Some people will attempt to do it. They'll say things like, okay, well, normally I just have to change the sign. So they'll say, okay, well, how about I just don't change the signs? What if I go plus 2, plus 2? Would that work? And the answer would be no, because if you tried expanding this, right? If you checked, you're going to get x squared plus 2x plus 2x plus 4. So notice the middle terms here don't cancel out. You'd get plus 4x plus 4. So you need to have one of these be the opposite sign in order for the middle term to go away, because there's no middle term here. But if these were the opposite sign, then that would make this negative. So this won't work. So this is not factorable. A sum of squares, not factorable over integers. So that's, don't make the mistake. People will make it. Don't be the person that makes it. I could throw examples at you that maybe don't look like perfect squares or difference of squares. So let's say 18 y squared minus 32y. So you, oh sorry, not y, just 32. You look at that and you say, okay, this is not a perfect square, right? 18 is not a perfect square. 32 is not a perfect square. But hopefully remember the golden rule, right? What do you always do first? Common factor. Always common factor first. So if I common factor first, I can take out a 2. Sorry, 9. So now I have 9 and 16, which are both perfect squares. So 9y squared would be 3y times 3y. 16, 4, 4. 1's positive, 1's negative. So by common factoring, that allowed us to factor as a perfect square. If you didn't recognize that, you wouldn't have been able to do it. So it's very important. Another reason why common factoring is always important to do first.